Hello, welcome back to the May 2025 IB Chemistry TZ2 exam walkthrough. This is for paper 1B, the HL version. However, I'm only going over the HL marks, the marks that are in common with SL, which is most of them. You can check out the SL version here. This video will just be covering these two extra questions that are in question 2 for HL only. So if you're SL, leave. Anyways, so this whole experiment for question 2 is generally about this spinach leaf being boiled in water for different times, titrating with potassium permanganate, and then seeing the concentration of Fe2 plus ions. And so this part 3 is essentially asking us to suggest an additional trial that should be performed so that it can be determined how much Fe2 plus was extracted only from the spinach leaves. Okay, and so the wording of only of the spinach leaves is essentially suggesting here that there is something else that may contain Fe2 plus ions that we are not taking into consideration. And so whenever you read this, the big thing that you should realize is that water contains a bunch of different things. And specifically, I believe it says tap water. Yes, it says tap water specifically, which is oddly specific. And so this is one thing that we're going to see is a trial with, let me just put trial first, trial with only boiled water and no spinach. Because then we can see how much is just from the spinach itself. Okay, this would essentially, where if there was some stuff in the water, we could then quantify that systematic error to then subtract from all of our values from the times, if that makes any sense. So that would be that part 3. This part 4 would be discussing 2 difficulties that a student might experience when determining the endpoint of this titration. Okay, so this one specific is this titration. Okay, and so this kind of reminds me of a really, I don't know how old. It's been a hot second, but it was an old paper 3 question where it was some titration with like blueberries or something, and like the endpoint was blue. And so it was like, okay, you can't detect the endpoint because blueberries, blue, you couldn't tell it would be blue before and after, right? And so immediately I was thinking of that one whenever I was approaching this question myself. And so I was like, okay, so the color change is with potassium permanganate, which this does require you to know. Does it tell you? Yeah, for some reason it doesn't tell you the color change that I can see unless I'm blind and illiterate, which is true sometimes. But and you all don't have to know it as an oxidizing agent anymore. So that was a little mean of them. But anyways, you should have done this titration though. Hopefully at some point in time. This is one of the redox titrations that is strongly recommended for you to do in class, and my students did. So you can't say you did. Is it goes from purple to colorless. Okay. And so one of the difficulties would be that rather than purple to colorless, is it would be like purple / green to colorless, which would make the colorless a different color than usual. Would have green and possibly just spinach water. It's going to be tinted green because spinach is green. Like alpha, it's like wicked. Sorry, okay. Possibly change endpoint color. Okay. And then the second one, this M2, this was one that, like I said, brain dump, you're more likely to get something right for this paper 1B as long as you're not contradicting yourself. I actually didn't get it in the end on my own version of this exam, unfortunately. Is the thing that they were looking for was, there were 2 options, was either the meniscus is hard to read, that like you have to read from the meniscus, if that makes sense. So burette must be read from meniscus. Which, okay, in retrospect, I do feel like kind of makes sense because those are the 2 most common type of things in the evaluation of a titration IA are always, oh, the color change was kind of wonky, and maybe I didn't read it from the meniscus. Those are the two kind of big things, and so that does kind of make sense now that I'm thinking about it. The other option that you could have put was that the KMNO4 solution may have been too dark to read, which I don't think makes sense. Oh, okay. So it would like cover. Okay, I see it now. Is the thought was that if it's too dark to read, then it may cover up the lines that literally show you the values on the burette, if that makes sense, because it's like dark purple sometimes, and it doesn't specify the concentration. So, and even dilute concentrations, it's still dark purple for some reason. And so that would be an option. And then the last option that you could have put was that you're working with organics, and so you have to perform the titration pretty quickly in order so they don't go bad, essentially, and also so that they don't start reducing, oxidizing like on their own, because organics do that when they do go bad. So that was also another option. I'll put a screenshot of the mark scheme here. But yeah, so that is the only two HL subparts for this question too. So that is it.